Good morning, friends. Today we are going to discuss last topic in the fifth model, that is AC generator. It's also called as a synchronous generator, also called as an alternator. Okay, it has three names you need to remember. Usually we mention it as synchronous generator or alternator. Okay, as we know, the DC generator definition means a generator definition. Similarly, in this way also, AC generator or alternator, which converts mechanical energy into electrical energy. Okay, so this one, why we call it as a synchronous generator? Because the alternator which works on the specific constant speed. Okay, that's why it is called as a synchronous generator. Okay, so now what is the difference between AC generator and a DC generator? Yes, means in the AC generator. Okay, so here we are going to use field on the as a rotating part. Okay, so field winding will be on the rotor. Okay, and remember armature will be on the stator. Okay, which are stationary, right? So and remember one more important thing is commutators are absent here. Okay, where in DC generator we have armature on the rotor. Okay, armature on the rotor, and field winding is on stator, and there were commutators present. Okay, remember the commutators were used just to convert the AC generated current into DC form. Okay, so whereas here we require AC directly, whatever is generated is there, that we are going to utilize. Therefore, here we are not going to use commutators. Okay, so now we'll see what are the construction of this AC generator or synchronous generator. Okay, we will move to construction of a synchronous generator. As we know, the machines has two parts. Here also synchronous generator has two parts. One is stator, another one is a rotor. Okay, stator and rotor. Rotor will be on the shaft, mounted on the shaft. Okay, here let's see what are the stator parts and what is the stator. Okay, as we know, the stator is a thin laminated core. Okay, combining together which forms a core, right? So within that, here these parts are your these are your rotor conductors. Okay, and these are your stator slots. Okay, these are your slots where you can place the conductors. Remember, armature conductors has to be placed in the stator. Okay, armature conductors has to be placed in stator conductors. Okay, and then these are your tooths of a stator. Okay, and remember this thin lamination is done because to reduce the eddy current losses. Okay, and the material which you are going to use for this is preferably as steels, because to reduce the hysteresis losses. This is about the stator construction. Okay, it is same as that of your three-phase induction motor, stator part. Okay, and then comes to the rotor part. Here again we have two types of rotors. Okay, one is salient pole type rotor. This one is also called as projected pole type. Okay, and another one is non-salient pole type rotor. Okay, it's also called as a smooth cylindrical type rotor. Okay, so which motor or which generator, or alternator uses salient pole type rotor, then that alternator is called as salient pole type alternator. Okay, it's based on types of alternators based on the rotor types which you are going to use. Suppose if you are using non-salient pole type rotor in the alternator, then that alternator is called as non-salient type alternator. Okay, so let's see first one, salient pole type rotor. So this has in the rotor, here we are going to use this type of arrangement. Poles are arranged as a projected type. Okay, so north and north, south poles. Okay, the poles are projected. Okay, and these are your field windings, as we have said. Okay, armature windings on the stator and field windings on the rotor. So field winding is wounded on these rotors. Okay, so similarly These are your field windings, and as we know, this is your shaft. Okay, remember there will be a mechanical support over here that we are not shown. Okay, so this is salient pole type rotor. Now we will see what is the non-salient pole type rotor. It consists of cylindrical shaped rotor. Okay, cylindrical shaped rotor. This type, remember, so it is of very less or very small radius cylinders will be inserted. Okay, and you can wind the number of field windings on this. Okay, and so on. Remember, if this is the south, north, south, and similarly this is also north. Okay, between that we have a small radius cylinders. Okay, this type. Right, so conductors are placed. Remember, this is the north. If the same conductors which are placed, that has to be placed here as well. Okay, same. So here if you are using another face of that conductor, has to be placed same. Okay. This is again, this is a rotor, and remember, sorry, so shaft on this. Okay, and that shaft we are going to give a small DC supply for the excitation of this alternator. Okay, so now we will discuss what is that excitation DC supply we are going to give. Okay, a small excitation, because initially we have to rotate the alternator. Okay, for a small amount. So for that small amount of supply we are going to give by DC supply to this rotor. And then similarly same here as well. Okay, so then when we give a supply to this, then your rotor field winding is going to generate a flux, and then due to that field is going to start rotating, and then your stator windings should be stationary. Armature winding will be there on the stators. Okay, whatever the flux is produced, that is cut by this stator conductors or armature conductors. So then there will be an induced EMF. As we know, this is also alternator or synchronous generators works on the principle of electromagnetic induction. Okay.